students, I am going to introduce you an innovation that has come out of IIT Hyderabad, which is a lightweight portable bridge. Many of you are aware that army and relief agencies, disaster relief agencies, come up with bridges which have to be installed on inhospitable terrains, and many a times this needs heavy machinery and transportation to such facilities which can be very long. And keeping that into consideration, the team at IIT Hyderabad, led by Dr. Anil Agarwal of Civil Engineering, with collaboration from Modulus Composites Inc. Hyderabad and GSRE Kolkata, have come up with a very lightweight, portable and rapidly deployable bridge which can be carried by a team of 12 people on their backs, and it can carry heavy vehicles on it, and that can help both the army and disaster relief agencies in a very comfortable manner, so that they can handle situation very easily in such kind of inhospitable terrains. And this is something which has been appreciated by a large number of agencies and being planned to be utilized in a large number of terrains, so that it can help the people in a big way.
As a civil engineer, we always have dealt with this major challenge of providing access to the humankind to the most inaccessible areas, regions of the earth. Now, there are such major challenges faced by army operations during rescue and relief operations, wherein we have to reach remote locations, inaccessible locations, sometimes at border areas, sometimes in hilly areas, and they have to often cross river bodies, water bodies and ditches, etc. In such kind of challenging situations, there is a requirement of providing a bridge system which can be deployed on a short notice, and which can allow them, these personnel, to cross these obstacles. Similar situations arise after any natural disaster such as an earthquake and a flood, etc. And timely intervention, timely deployment of such resources can basically make a difference of life and death. Now, there are some such systems already available in the market. One such system is a mobile bridging system, which is used by various international militaries. Also, there is one such traditional system that is known as Bailey Bridge. Now, both these systems that I have discussed just now, they are heavy metallic steel structures, and as a result, they become very difficult to move around. They usually require a lot of mechanized machinery systems, some trucks, etc., to move them around, and also launching them or deploying them at the site becomes extremely expensive and extremely difficult. With the recent advancements in the area of advanced materials such as lightweight composites, we figured that it would still be possible to develop a system which would not require such kind of a machinery or such kind of a manpower, and could still be deployed in very remote areas with the minimum use of manpower. And for this particular problem, there are three agencies. One is Modulus Composites. They are manufacturers of such kind of composites based in Hyderabad. One PSU known as GRSE. They are Garden Reach shipbuilders and engineers based in Kolkata, and IIT Hyderabad. We came together to develop a bridge system that could be used in such kind of conditions at a very short notice. Such kind of bridges are supposed to, so basically we took up the challenge so that these bridges would be able to support the weight of an all-terrain vehicle or a gypsy kind of a four-wheeler. And but the biggest challenge that we took up on ourselves was to build this bridge in such a way so that a small contingent of 10 to 15 people should be able to carry and deploy this bridge on a very short notice. And essentially that made the requirement of this bridge to support almost 4 to 5 times of its self weight. We used a lot of new innovative technologies in the development of this bridge, And we have not only developed all these technologies, we have also developed a prototype which is already deployed.
To meet the challenging requirements of the armed forces, we have developed an advanced composite bridge using carbon fiber. We had to develop several structural components, the main structural members, the bridge deck, and the joints using aluminum alloys. The end result of this development and extensive testing at IIT Hyderabad is the development of a 9-meter span bridge which can carry a load of 1.1 metric ton and has an approximate weight about 300 kgs. This bridge can be carried in segments of 12 and can be assembled in the field with minimal tools and can be deployed across from one end of the gap without the need for access for the other end.
So the bridge system that was developed was extremely lightweight, and it was able to support almost 4 to 5 times its self weight. In order to achieve this kind of material efficiency, various technological innovations were employed. One such innovation was using of syntactic foam in composite action with CFRP laminates. So as you can see in this bar, there is a syntactic foam core at the center and there is a CFRP laminate wrapped around it, and the two components act in composite action. In addition to that, also the gazetted connections between the members to complete the truss were also very complex, and their design and manufacturing involved several challenges. There were two different types of gazettes. There were permanent gazettes and there were gazettes connections which could be opened in the field and connected again. And for the permanent gazettes, we had used only CFRP composites, whereas for the gazettes which could be opened, aluminum alloy, high strength aluminum alloy plates were used in composite action with CFRP laminates. That was a very complicated connection, and we overcome. These connections are bolted connections which can be opened and closed in the field. In addition to that, there was also a major challenge in bonding the top deck with the truss, and various manufacturing innovations including vacuum infusion etc. were employed to bond the two components together to achieve a full composite action.
Apart from military applications, this technology has immediate applications in the field of disaster management. This can be readily deployed in areas affected by disasters to provide immediate relief and deploy personnel to the affected zones. And this technology is ready to be deployed for military and disaster management applications. Further development and optimization will help this technology to be deployed in highway bridges and other applications.